So we can consider a population of interest, we could sample from it, we could measure different factors, different variables. Why do we do it? Well, we do it because we have a certain hypothesis about the process that involves that population and those factors, right? And so what is a research hypothesis or a research question? It's essentially a statement that tells us what is or is not expected to happen in that process. So it's about tentative relationships between the factors in our study, normally between the independent variables and the dependent variable. So think, for example, we might hypothesize that the recovery time is different in adults and children. And so we are saying, or we're questioning whether there could be a relationship between the dependent variable, time to recover, and the age of the patient. Let's divide maybe in adults and children. Maybe we hypothesize that if we are encoding music files in MP3, then the higher the bit rates, then the louder the signal in some music genres. So what we're saying here is that the dependent variable, the loudness of the signal, depends on two factors, the genre of the music and the bit rate that we are encoding that music on. So it's all about these kind of relationships. There is a certain relationship, there is not, there is a relationship mediated or moderated by this other factor, etc. And so the important point about the hypothesis is that they must be falsifiable. What does that mean? It means that it should be possible to disprove them through observation or data. So if we make a hypothesis, it should be such that if we make an observation that contradicts that hypothesis, we could just say we're disproving the hypothesis. Any hypothesis that is not falsifiable, it's not within the domain of science. And so they are always open to the possibility of just being wrong. So for example, think about the hypothesis, all swans are white. We know the story. Back in the 17th century, people thought that swans were white because in Europe all swans were white, until this Dutch salesperson went to Australia, I think it was, and he saw black swans. And so the hypothesis, all swans are white, is falsified in this case through the observation of a black swan in Australia. Maybe this other hypothesis, biking to work takes as long as riding the bus. It can be falsified if we observe a difference. So if we see people riding the bus take this long and people biking to work take this long, then if there is a difference, we are disproving this hypothesis. And why is this important? Well, because the absence of evidence is not evidence of the absence. Let me elaborate. The fact that we don't observe something in a study, the fact that we don't see a certain effect, it doesn't mean that the effect is not there. It just means that we were unable to see it for a variety of reasons. Maybe the effect is smaller than we thought. Maybe we don't have enough data for it. Maybe our sample is not good enough or is not representative and we just don't see it. So the fact that we don't observe something doesn't mean that it doesn't exist. Think about the hypothesis, there is a reptile in Lake Ness. Well, that's not a valid statement because it cannot be falsified. So someone tells me there is the so-called monster, the reptile. If we don't see it, well, it's just you didn't see it, or she didn't want to go out that night, or she is hiding and she doesn't want you to see her. There's a variety of reasons why someone could say, well, you just got unlucky in your study and that's why you don't see it. So the fact that we don't see her doesn't mean that she doesn't exist. And therefore, this is a win-win situation for whoever is posing this hypothesis because it cannot be falsified. They could always give you a reason for why we are not observing the reptile. And falsifiability links directly to statistical analysis because we have the same situation when we analyze data from a statistical point of view. Everything about statistical hypothesis relates to a lack of effect, and we reject this hypothesis when we find an effect. So typically we hypothesize there is no effect, and then through observation, if we see there is, then we disprove that hypothesis. But we can only show that there are effects. We cannot show that there aren't. So we are in the same situation. So statistically, if we say treatments A and B are equally effective, this can only be falsified. This cannot be proved. And so through statistics, we are not going to be able to show that there is no effect or that two things are equal. We're only going to be able to say the two things are different or that they are equal to a certain degree, that the difference between them is sufficiently small for us to not observe it. Again, we'll see plenty of more information about this. So what I'm saying with this is that sitting down and clearly stating the hypothesis, our research questions, is one of the most important steps in any study. So we should sit down and think very carefully about what is it that we want to study. And when we start thinking about it, we start seeing that there are many sources of variability. Variability doesn't just come from sampling from population. It comes from all these other factors that are presumably affecting the response as well. So we should start asking the question, what do the dependent variables depend on? And something that I personally find very useful is to state those relationships in terms of just a function, a mathematical function, something like the dependent variables are a function of the independent variables. So to speak, this would be the outcome of our study. This could be the factors. So all the factors, and this F would be the process that we are studying. And so let's go again to the example of the quality of coffee. Our hypothesis is that the quality of coffee is a function of the brand of coffee. That's perfectly fine. Now, what we should do is be as thorough as possible and think about any third variable that could potentially influence the relationship between those two. So we should start trying to be more comprehensive about what factors we consider, because we see or we saw in a previous video that there's plenty of third factor effects that could be fooling us into establishing a relationship between the dependent variable and the dependent. So it's actually the quality of the coffee depends not only the brand, but depends on the roasting, it depends on the country of origin of the coffee beans, it depends on the brewing time, etc., etc. And we should include variables even if we cannot control them, or even if they do not vary, they are constant, or even if we have no possibility of observing them. So for instance, something that we cannot control is probably the temperature of the water that goes through the machine. It's just whatever the machine does, but we can observe it probably. Or maybe we cannot observe it, but it's something that for sure affects the quality of the coffee. We should record it because maybe in the future we are able to control for that. So the question is really, what factors could possibly affect the dependent variable? Think about it, and if you can measure them, measure them. If you cannot, at least be aware that they could be affecting your study. So it's going to help us make sense of the data, and it's going to help us realize what assumptions we are making in our research hypothesis. So again, the temperature, of course, affects the quality of the coffee, but it's probably something that we cannot control in the machine. Still, we should be aware of this, so by the time we write our claims, we are open to the possibility that maybe the relationship we are observing depends on the temperature, or it's only because we are operating under a specific value of the temperature. And so the quality of the coffee could be a function of the brand, roasting, country of origin, brewing time, the machine, the brewer, the water, the temperature, the pressure, etc., etc., etc. Again, some of these we are not going to be able to measure, some of these we cannot control, but still we should be aware of all these possible relationships. Why again? Well, because the picture we saw, it's not really like this. It's not just, in this case, the quality of the coffee, that depends on the brand of coffee and the machine, etc., etc. There's plenty of other factors that we have no idea about. The more thorough we are, then the better, because our claims are going to be more sensible. And so the point is, what we're actually studying is what is the effect of the factors of interest on the response while controlling for all the other effects. The more of these factors we can control for, then the better our estimation of the relationship between the controllable factors and the outputs. And in the end, it's just about accepting that our study is going to have a certain amount of error. every study has a certain amount of error. Just accept it. And we categorize typically the error into either systematic or random. Systematic error is one that is introduced by a bad measurement instrument or poor experimental procedure, the environment, the experimenter, etc., etc. So those are things that are in there, so to speak, because the study is not well defined or very well planned. And the point is that if we identify these biases, these systematic errors, we might be able to eliminate them in a certain way. But then we have random errors. Those relate to something more like noise. Those are inherent and unpredictable fluctuations in the data, for example, due to sampling from a population. We cannot control them. We cannot explain them. That's why we call them random, because to us, those variations look like random. But the point is we can reduce them. And for instance, we saw that one way of reducing this random error is by collecting more data, by having larger sample sizes. So again, it's not that these errors are really random, it's just they look random to us because we cannot explain them. And so really, in the end, this relationship we're trying to establish between the independent variable and the dependent variable looks something like this. So it's a function of those factors, but keep in mind, always, there's going to be a certain amount of systematic error and a certain amount of random error. And the important point to make here is that statistical analysis has to do with the random error, not with the systematic error. Everything about properly designing your study is what's going to determine this systematic error.